Greetings and welcome to my new calculus channel. My name is John Gabriel, and in the last video we left off after completing proposition 13, and so we'll continue with proposition 14 of Euclid's Elements and book 5. So let's begin. Okay, oh, that's neat. Before I continue, let's see here. Oh yeah, I just had a negative COVID test. Okay, that's good. It helps to stay negative. Right, now, so what does proposition 14 say? Well, proposition 14 spells out the relationship between magnitudes, which I have already demonstrated in the previous proposition. So basically what it says is that if the ratio alpha to beta is equal to gamma to delta, then alpha is equal to gamma and beta is equal to delta. And if alpha is greater than gamma, then beta is also greater than delta. And if alpha is less than gamma, then beta is less than delta. Okay, so in Greek you don't actually say D, you say delta, not delta. Okay, so that's a pretty simple proposition and also useful. And what this also gives you an idea of is that the relationship of what happens later on when you take the measure of these ratios as fractions. And so if you take the measure of one ratio and it's equal to the other, then you'll have these relationships. So proposition 15 tells us that certain parts of a ratio, of the same ratio or similar multiples, have the same measure. So for example, if you have the ratio alpha to beta, and you take a multiple of the magnitude alpha and a multiple of the magnitude beta, it will be in proportion to this ratio, and their measure will be the same. So let's see an example. So if we've got 1/3, that's a multiple of 1, right? M would be 1 there because it's just equal to itself. So if alpha is this distance and beta is this distance, then the multiple is just 1. If we multiply both of them by 2, right, then it's the same as adding 1 to this side and adding 1 to this side, right? So 1, 2, okay? And similarly, a multiple of 3 will result in this last ratio, and their measures are all the same. They're not equal ratios, by the way. They're in proportion, and their measures are the same, but they're not equal. Now, proposition 16 says if four magnitudes are proportional, they will be proportional alternately, and of course we've covered this already in proposition 12, so I'm not going to spend time on it. It's very easy. Proposition 17 says that if composed magnitudes are proportional, then they will also be proportional when separated. So Heath doesn't actually get this one right, because what he says is that according to modern notation, this will be the relationship between the two ratios where k is any number. But is this proposition just telling us the following, that if we have 3/4 plus 2 or any value of k here in proportion to this, then the measures are as follows? Is it just telling us that? No, I don't think so. It's telling us about the composition, meaning that if you take 3, you can split it into this linear combination, which is 2 plus 1, and likewise 9, which is 6 plus 3. And so generally, you'll have that this relationship implies this relationship and this relationship. Okay, so taking the measures of the above ratios, as in algebra, gives you this result. Okay, so proposition 18 is very easy because it's the inverse of proposition 17, and so I'm not going to spend any time on that. And proposition 19 says if as the whole is to the whole, so the part is to the part taken away, then the remainder will also be as the whole is to the whole. So this proposition is superfluous, given that it is implied by previous propositions. So it's nothing remarkable. And so the next two propositions are 20 and 21, and these are the same as proposition 14, but with 3 magnitudes instead of 2. So I think I'll stop here, and in the next video I'll complete the last 3 propositions of book 5, the most important book of Euclid's Elements. If you're not already a subscriber, become one. Click like on my channel, by the way. I don't earn anything, in case you're wondering. But I want to get this out to as many people as possible, to as many aspiring young mathematicians, because this is about the foundations of mathematics. And nothing in Euclid's Elements tells us how we got algebra, as does book 5. Okay, so book 5 is by far the most important book out of all the books, out of all the 13 books in the Elements. I'm John Gabriel. This is New Calculus Channel. Till next time, goodbye.